Hey everyone, it's Justin again. Now that we've learned a little bit about the sine, cosine, and tangent, let's review some topics that'll be very helpful in finding specific values of these functions. If any of this appears new to you, don't worry. This lesson is designed so that you can still learn it for the first time if you've never seen it before. Let's get started. By the end of this lesson, you should be able to find the third side of a right triangle given two of its sides. First, we'll review the Pythagorean Theorem, and then we'll complete some examples. Recall that a right triangle is a triangle with a right angle, marked here. On a right triangle, the sides have special names. The hypotenuse is its longest side, which is opposite the right angle, and the two sides that make up the right angle are called the legs of the right triangle. Using these terms, the Pythagorean theorem says, in a right triangle, the sum of the squares of the length of the legs is equal to the square of the length of the hypotenuse. What a mouthful. While this is a very formal statement of the Pythagorean theorem, it's actually as easy as ABC with powers. We label the legs with A and B and the hypotenuse with C. It is very important to make sure that C always represents the hypotenuse. Using this, we get a formula that you've probably seen before. A squared plus B squared equals C squared. For example, here is every mathematician's favorite right triangle, the 3, 4, 5 triangle. Notice that 3 squared plus 4 squared equals 5 squared, since 9 plus 16 equals 25. As we'll soon see, most triangles don't come out this nicely, but anytime you can make a right triangle with integer sides, we call those numbers a Pythagorean triple. Can you think of some others? You may have come up with 6, 8, 10, or perhaps 8, 15, 17, and we'll see another one on the next slide. Finally, notice that we wrote 3 squared plus 4 squared, even though 3 is actually labeled B and 4 is actually labeled A. We could have just as easily written 4 squared plus 3 squared and gotten the same answer. So while you should always label the hypotenuse C, it doesn't really matter which leg you label as A and which leg you label as B. Let's do an example. Find the value of x in the following triangle. When we do a Pythagorean theorem question, remember to always use the hypotenuse for your value of C. So which side is C? It's the side opposite the right angle, the side which has length x. Now we can label our legs in either order, so we'll let A be 5 and B be 12. Now, let's use our formula. Try pausing the video to see if you could find the value for x. Okay, we'll substitute our values in for A, B, and C. Then we'll calculate the values of these squares. Next, we have that 25 plus 144 equals 169, and we went ahead and switched the order of the equation. What's the final step? We take the square root of both sides, which gives us x equals 13. And that's it. Here's another example. Find the length of the missing side in the following triangle. Notice that we're given the hypotenuse this time. Pause the video and give this one a try. Okay, let's label our sides. Remember, the hypotenuse has to be our C value, so we get that C is 18. If you made this mistake, try pausing the video now and fixing it. However, if you switched your A and B from what we have here or just labeled your missing side differently, that's totally okay. As long as C is 18, you will find the right answer. Now, let's use our formula and substitute our values in for B and C. Then we'll calculate the values of these squares. This time, we'll subtract 9 from both sides. Just like last time, let's take a square root. You got this answer, great. However, we can simplify it further. Notice that 315 is 9 times 35, so we can factor a 9 out and take its square roots. That gives us that A, our missing side length, is 3 times the square root of 35. Remember, when using the Pythagorean theorem, A and B are always the legs, C is always the hypotenuse. So in a right triangle, we get the equation A squared plus B squared equals C squared. In the next lesson, We're going to use this to review one final piece before we start building up some special values for the sine, cosine, and tangent. See you then. Hey.